All right, let's keep going with problem 60 on the 5-4 homework. So we want to do the cosine of arc cos x minus arc tan x. And so what we have here is a cosine u minus v problem. So the formula for cosine of u minus v equals cosine u cosine v plus sine u sine v. The problem is, what is cosine u cosine v? We need to be able to get that from these. And anytime you see the arc cos, we can go ahead and draw a triangle. So I'll put them down here. This will be triangle, the first one, u, and this will be triangle v. All right, so from theta, we have the arc cosine being x. That means the adjacent side is x over 1, which means if we do the Pythagorean theorem, we're going to have 1 minus x squared. And then for v, the tangent is x over 1, so opposite over adjacent is x over 1, which would give us the square root of 1 squared, or just 1, plus x squared for the hypotenuse. And so from these, we can come up with the cosines and sines of each triangle. So for the cosine of u, we would have the adjacent x over the hypotenuse, 1. So cosine u is x over 1, or just x. Cosine of v would be 1 over the hypotenuse here, over the square root of 1 plus x squared, plus the sine of u is the opposite, 1 minus x squared over 1 times the sine of v, which would be opposite x over the square root of 1 plus x squared. And then we'll just clean this up. So in this case, we do have a common denominator of square root of 1 plus x squared. And in the numerator, we're going to distribute x times that becomes x root 1 minus x squared plus just 1 minus x squared, because it's times 1. And we'll leave that on top. Okay, and so in this one, we really don't want the radical in the denominator. If we keep going at this point, it's going to get really ugly. So I'm going to say let's just leave it right here for now, understanding that really we should multiply top and bottom by 1 minus x squared, so we can cancel out, use our conjugate. Okay, but the point here is when we have arc cos and arc tan, let's go ahead and draw our triangles. And then what's our formula for cosine of u minus v? It's cosine u cosine v plus sine u sine v. That's the important part. Let's keep going here to problem 70, if the computer will cooperate. Come on up. There we go. All right, so this one, let's prove this identity. So remember, we work the more difficult, the uglier side first. So let's clean this up. The cosine of x plus y, it turns into the cosine of x cosine y minus sine x sine y. So that's our first formula. Plus cosine x minus y turns into cos x cos y plus sine x sine y. All right, there is nothing to be distributed, no multiplying, so we really don't need the parentheses. Let's go ahead and collect our like terms. A negative and a plus cancels out. There's 1 here and 1 here. Add them together, that's 2 cos x cos y. And in just 2 steps, we have proved that the left side is equal to the right side. Problem 80. All right, let's find all our solutions here. So first we need to change sine u plus v into sine u cosine v. So sine x cosine pi over 3 And is it a plus? Let me check the formula. Yes, it is. Plus cosine x sine pi over 3. So that's the first expansion. Plus sine x cos pi over 3 minus cos x sine pi over 3. That equals 1. Let's see what we can cancel out here when we collect our like terms. Those two go away. So now we have 2 sine x cosine pi over 3 equals 1. If we go look at the unit circle, or our cheat sheet, the cosine of pi over 3, that's the cosine of 60 degrees. That's 1/2. So 2 sine x times 1/2 equals 1. So 1 sine x equals 1. So sine x equals just 1. Let's get x by itself by using the inverse sine. And where on the unit circle is the y value equal to 1? The only place that happens is at 90 degrees, which is at pi over 2. And I could say, let's say, plus 2 pi n if I wanted all the solutions, but I only want all the solutions between 0 and 2 pi. So it's only the first one there, the plus x equals 90 degrees, x equals pi over 2. Moving on to 90. All right, problem that looks very, very complicated. Turns out really not to be. They're saying, let's do y1 plus y2. And y1 is this. And we see here a cosine of a minus. So we just need to do the expansion. Things are going to cancel here pretty quickly in this problem, luckily for us. So let's take a look here. We'll say y1 is a, put a big bracket because it kind of gets long here, cosine of 2 pi t over big T, and then it becomes cosine again of the second part. And since it's a cosine formula, if it's a minus, originally we turn it into a minus with the signs. Sorry, I forgot my 2 pi here. This 2 pi is going to be distributed to everything we see. 2 pi t over big T, and that's our expansion for the y1. And let's go ahead and do the plus. I'm going to use the second line here. Plus a to everything. And then we're going to also do the exact same thing, but now it's a plus. So cos 2 pi t over t cos 2 pi plus sine 2 pi of u sine 2 pi of v. All right, so let's go ahead and see what we can cancel. It's this first term here, and you'll notice that we have 1a and another a, which becomes 2a. We have cos and cos again, so we have proved that they are the same. All right, so just really 2 lines. Kind of looks ugly, but just making sure we're using the expansion rules for cosine of u minus v and cosine of u plus v. 100. All right, so they say go look at 97 and 98 for some formulas here. If we go back and look at those problems, they say that this first formula is equal to a sine b theta plus little b cosine big B theta, where C, this C here, equals the arctan of little b over little a. Alright, so we're going to match this up. 3 is our little a, so we go back into our formula and say square root of 3 squared plus 4 is our little b, so 4 squared sine, our big B is the 2 here, theta, plus, says C is the arctan of b over a, and we said a little b over little a. We said little b was 4 and a little a was 3, and so we're going to plug that in. 3 squared plus 4 squared, that's a Pythagorean triple. 3, 4, 5 right triangle, sine 2 theta, plus, how are we going to get the arctangent of 4/3? It's not on our cheat sheet. It's not a regular occurring number, so we're going to plug it into our calculator, and we'll get 0.9273. And that's it. That's all I wanted us to do on that one. So we want to be able to use our formulas. All right, so for the second one, it works exactly the same way, except the formula said if it's a minus here, then we flip the C around to make it arctangent of A over B. So we'll get the exact same answer, 5 sine big B theta, but we'll get a slightly different C because it's now 3 over 4. So plug that into our calculator and we'll get, excuse me, it's a minus in the formula, minus 0.6435. All right. Last problem, 106, again, looks lengthy, not too bad at all. Let's start with the domains of the functions. So let's look at f first. We see an h in the denominator, so right away we need to think back. Our domain, h cannot equal 0, can't have 0 in the denominator. The other thing we have to look at, are there any places where cosine is going to be undefined? All right, is there any place where we would be dividing by a 0? And since cosine is the adjacent over the hypotenuse, hypotenuse could never be 0 on a unit circle. Cosine is never undefined, so we're okay. Same thing with sine down here. Cosine, cosine. So again, we just look at the denominator. We say h can't be 0. Otherwise, it's all real numbers. All right, let's go ahead and use a graphing utility to complete the table. I'm going to switch over to my graphing calculator. All right, so you'll see here I've typed in the first, this is the F, and this is the G formulas here. Just be careful with what you're plugging in to our parentheses. I've gone to my table set here and started with 0.5 and counted down by 0.01. So we can see our numbers. They wanted 0.5. If we go in here to our table, and so I could scroll down through these to get our values for 0.4, negative 0.6577. I'm going to keep going to get 0.3, 0.6215. We look here. Here's our graph. Okay, I'm going to zoom out a little bit. And let's use our old friend, negative 10 to 10. And negative 10 to 10, and so it'll look like this. And so our last question says, as we approach 0 on the x, what is the y value getting close to? And so if we check back into the table, the values that we got, let me fill these out, were negative 6.9, negative 0.58, negative 0.54, negative 0.52, negative 0.51, and negative 0.50. The second column was exactly the same for all of these, since they are indeed the exact same graph. And so our last question says, as we are getting closer to 0, what are the y values getting closer to? Well, we can see that they're getting closer and closer to negative 0.5. That'd be our final answer there. All right, that's it for 5 homework questions.